In this videotape, we're going to review the rules for exponents, and I'm going to be giving you the definitions of zero and negative exponents. Now, if you find that we're going a bit quickly, there is a more detailed videotape on this topic in the elementary algebra sequence. As we go along, I will illustrate the rules and definitions with simple examples. The second videotape, Integer Exponents Part 2, okay, the tape right after this, handles some more complicated examples using these same rules. Here we'll just give you the rules, the definitions, and some very simple examples. Definition of a to the nth power. By this I mean a times itself n times. There are n factors of a. A to the second power, okay, is read a squared. And a to the third power is read a cubed. So, for example, if I have x to the fourth power, I mean x times x times x times x. There are 4 factors here. 2 to the fifth power, 2 times 2 times 2 times 2 times 2. 2 times 2, that's 4, times 2, 8, times 2, 16, times 2, for an answer of 32. Minus 3, in parentheses squared, means minus 3 times minus 3. Minus 3 to the second power, that is plus 9. Minus 3 times minus 3, that's plus 9. However, minus 3 squared, okay, by order of operations, this multiplication is going to occur first, and then we'll take the opposite of that. It's minus 3 times 3, which is minus 9. Notice the difference here. This is minus 3 squared, minus 3 times minus 3. This is minus, or the opposite of, 3 squared. So square your 3, get 9, and take the opposite of that for minus 9. Okay. If a is not 0, a to the 0 is defined to be 1. Okay. If you want a justification of this, I would suggest you look at the tape on zero and negative exponents in the elementary algebra sequence. Right now we are just defining a to the 0 to be 1. It's defined this way so that all the rules that you've had for positive exponents also work for negative and 0 exponents. A to the 0 is 1, and also if a is not 0. Well, let me give you some examples of this rule first, and I'll give you the next definition. Okay, 8 to the 0 power, that's 1. X squared plus 4 to the 0 power is 1. Any non-zero quantity to the 0 power is 1. 5x to the 0 power, assuming x is not 0, 5x to the 0 power, that's 1. Okay, but 5x to the 0, this means 5 times x to the 0, 5 times 1, or 5. Okay, notice the difference. This is this whole thing to the 0 power, and something to the 0 power is 1. This, however, is 5 times x to the 0. So first you do x to the 0, and that gives you 1, and then you multiply by 5. So 5 times 1, and the answer is 5. And as our third definition, if a is not 0, a to the minus n power is 1 over a to the n power. Okay, so x to the minus 3 power is 1 over x to the 3 power. Or x to the minus 3 is 1 over x cubed. 2 to the minus 4 power is 1 over 2 to the 4th power. 1 over 2 times 2 times 2 times 2 which is 1 over 16. Minus 3 to the minus 3 power is 1 over minus 3 to the 3 power. Don't get confused here, okay? The power here, the minus 3, this is what we're using here. This is a to the minus 3 power is 1 over a to the 3 power. Then the minus 3 in the parentheses we'll worry about. But right now, we first change this to the positive power and move it downstairs. Then it's 1 over, now it's minus 3 cubed. It's minus 3 times minus 3 times minus 3. 1 over minus 27. Or minus 1 over 27. You can write it either way. When we're going to be working on simplifying problems involving 0 and negative exponents, and we will consider an answer to be in its simplest form if it involves only positive exponents, okay? There's nothing wrong with negative exponents. You're usually not very convenient to work with. So we'll consider an answer. For example, if you had 2 to the minus 4th in a problem, I would want you to leave it in the form 1 over 16. Okay, so a problem, the answer will be in simplest form if it has only positive exponents. Okay, now I'm going to give the rules. Most of you will be familiar with them. And as I give them to you, I'm going to give examples. Okay, rule 1. By the way, in the rules that I'm going to give you, we will assume that A and B are real numbers. And M and N are integers. Rule 1. A to the m power times A to the n power is A to the m plus n power. Okay, as an example, x squared times x cubed, according to this rule. Okay, this is important. The bases are the same. These are the bases A. The powers are m and n. Okay, when you're multiplying like bases, you keep the base A, you add the powers. You keep the base x, you add the powers, 2 plus 3, and you get x to the 5th. And it's very simple to see why this makes sense, since x squared is x times x, and x cubed is x times x times x. Then we certainly do have x is a factor 5 times, or x to the 5th. So it seems like a logical rule here. Okay, let's use this again. By the way, it can be extended if you have more than 2 factors here. For example, x cubed times x to the 5th. Okay, we have the same base. We're going to add the powers. Remember that if you see x by itself, it means x to the 1st power. So it's 3 plus 1 plus 5, or x to the 9th. Okay, now these rules that I'm giving you are for m and n, for powers that are integers. They don't have to be just positive. They can be negative as well, okay, or 0. So let's look at x to the 6th times x to the minus 4. Still, same base. You keep the base, you add the powers. X to the 6 and minus 4. If you want to add 6 and the minus 4, okay, you get 2. X squared as an answer. Okay. Now, you can look at this in another way. This is the more convenient, to actually just use the rule. But just if you want to see a little justification of this, if you're not that familiar with the negative exponents, remember, this could be thought of as x to the 6th. Now, x to the minus 4 is the same as 1 over x to the 4th. Right? We have that over here. This was the definition that I gave you. A to the minus n is 1 over a to the n. X to the minus 3 is 1 over x to the 3. So x to the minus 4 is 1 over x to the 4th. And then, of course, if you have x to the 6th over x to the 4th, that's x is a factor 6 times divided by x is a factor 4 times. And, of course, you will simply be left with the x squared. Okay, but it's preferable for the more complicated problems that are coming up if you get used to using the formula. Basically, if you see a negative power or a positive power, you should treat it the same way. Okay, you shouldn't say, well, I'm going to bring this down here and cancel or something like that. Treat them exactly the same way. If you have positive powers, you add them. If you have a negative power, you still add them. If the bases are the same, okay, and you're multiplying, you keep the base and you add the powers. There you have rule 1. Okay, now rule 2. A to the m over a to the n is a to the m minus n. You're dividing now. The bases are the same. You keep the base and you subtract the powers. Okay, for example, x to the 8th over x to the 3rd, or x cubed. Okay. This tells us to keep the base x, to subtract, to get 8 minus 3, that's x to the 5th power. And this is not too hard to justify if you realize that x to the 8th is x, 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 x cubed, x, x, x. So you certainly are left with x to the 5th power. Okay, x to the 8th over x to the cube, x to the x cubed, or x to the 3rd power is x to the 8th minus 3, or x to the 5th power. Okay, y cubed over y to the 5th is y to the 3 minus 5, or y to the minus 2 power. And in keeping with our idea of giving our answers only with positive exponents, we'll write this as 1 over y squared. There is nothing wrong with y to the minus 2. But for work that's going to follow later, it would be more convenient to write it in this form. And of course, this is y times y times y over y written as a factor 5 times. And if you cancel, you would wind up with y as a factor twice in the denominator. Okay. A to the minus 3 over a to the minus 5. Okay. Now, it's certainly simpler to use the rule than to write this, say, as 1 over a cubed, and this is 1 over a to the 5th, and to work with a complex fraction. Okay. Let us just use the rule. We want to divide, keep the same base, and subtract the power. So minus 3, take away a minus 5. This is a to the minus 3 plus 5. You're subtracting a negative. You add the opposite, so you're going to be minus 3 and the plus 5, and you wind up with just a squared as your answer. Okay, now rule 3. A to the m raised to the nth power is a to the mn power. Okay, now let me give you an example of this. X squared cubed. X squared to the 3rd power. Okay, this is x to the 2 raised to the 3rd power. This is x to the 2 times 3, or 6th power. Okay, as a justification, think of this as x squared cubed. X squared cubed, and of course this is x times x, x times x, x times x. We do get x to the 6th power. Now please don't confuse this with what we had over here, which was x squared times x cubed. Okay, here you have the base appearing twice. You're multiplying. You keep the base and you add the powers. This is x squared times x cubed. Here we have x squared to the third power. Okay, here the base only appears once. Okay, it's not x squared times x cubed, but x squared to the third power. The base appears only once. You multiply the powers. Okay, x to the minus 2 to the minus 5th power. This gives you x to the minus 2 times minus 5, x to the plus 10, x to the 10th power. And if you have x to the minus 3 squared, this is x to the minus 6. Once again, we are multiplying the powers. And in keeping with our tradition of writing the answers with positive exponents only, this is 1 over x to the 6th. Okay, now rule 4. AB to the nth power is a to the n times b to the n. Okay. A product to a power. You take each of the factors to the power. Okay, for example, xy to the 4th power. According to the rule, it is x to the 4th power, y to the 4th power. And you can see the sense in this. This is xy to the 4th power. It's xy times xy times xy times xy. So you have x as a factor 4 times and y as a factor 4 times. Okay, let's try 2x to the 4th quantity to the 3rd power. The whole thing raised to the 3rd power. This is like your a, b to the nth power. So it's going to be a to the n times b to the nth. A, b to the nth, a to the nth, b to the nth. Now, in evaluating b to the nth here, notice that we have an example of an illustration of Rule 3. We have x to the 4th to the 3rd power. Just reminding you over here how Rule 3 worked. If you had the same base with the 2 powers, you multiplied the powers. Okay, so we have 2 cubed, that's just 2 times 2 times 2, or 8. And x to the 4th to the 3rd power is x to the 12th power. You multiply 4 times 3. You don't add the 4 and the 3. If it was x to the 4th times x cubed, that would be x to the 7th. But this is x to the 4th cubed. That's x to the 12th. You multiply the powers. Okay, let's try some more examples. X cubed y to the 4th squared. This is once again your a, b to the nth power. A to the nth, b to the nth. So x cubed squared times y to the 4th squared. A, b to the nth power, a to the n, b to the n. And now we're going to use Rule 3 again to get x cubed squared, that's x to the 6th. We multiply the powers. Y to the 4th squared is y to the 8th. Okay, now I want you to understand that the rule that I gave you is a, b to the nth power. Okay, it's only for products. Okay, we have a, b to the nth power is a to the n, b to the n. Okay, it is not true that a plus b to the nth power is a to the n plus b to the n. Okay, you don't distribute, you distribute the powers through the multiplication, but not if it was an addition. For example, if this had been x cubed plus y to the 4th squared, it would not be x to the 6th plus y to the 8th. You can't just send it across like that. Okay? This will be handled in a future videotape. Okay? Those of you who remember your elementary algebra, we would square this by using the FOIL method, and we would wind up with the outer and inner terms. And doing it this wrong way, you've only got the first and the last terms. You don't have outer and inner. Okay? So right now, we'll handle this later, but I just want to remind you that you don't do a sum this way, only a product. If it was x cubed y to the 4th squared, then you can distribute the power, but not if it's a sum. Okay, let's try one more example like this on this, and then we'll go on to Rule 5. How about a to the minus 3, b to the 4th to the minus 2 power? Remember, these rules are for positive or negative powers. It doesn't matter. Okay, this is like ab to the nth power, so it's going to be a to the minus 3 to the minus 2 power times b to the 4th to the minus 2 power. Okay, a to the minus 3 to the minus 2, b to the 4th to the minus 2. Now you multiply. This is using Rule 3. Okay, you have the two powers together. You're going to multiply the powers. You get a to the 6th, b to the minus 8th. And of course, this can be written as a to the 6th times 1 over b to the 8th. Because b to the minus 8 is 1 over b to the 8th. We want to keep our tradition of having answers with only positive exponents. So our final answer comes out a to the 6th over b to the 8th. Back over here, b to the minus 8th power is 1 over b to the 8th. Remember, we're really multiplying fractions in the sense that a to the 6th is really a to the 6th over 1. So we have a to the 6th times 1 divided by 1 times b to the 8th. Okay, our last rule, Rule 5, is similar to Rule 4, but we're doing it for quotients now instead of for products. That is, a over b to the nth power is a to the n over b to the n. We'll assume here that b is not 0. We never divide by 0. A over b to the nth power. Okay, if you have a fraction to a power, you take the numerator to the power over the denominator to a power, to that power. Okay, for example, x over y to the 3rd power is x to the 3rd power over y to the 3rd power. And it's not too hard to see, since x over y to the 3rd power is x over y times x over y times x over y. And when you multiply fractions, you multiply the tops and you divide by the product of the bottoms. So that, of course, would give you x cubed over y cubed. Let's try another example. X squared over 2y to the 4th to the 3rd power. And this will be the last example. Okay, we have a fraction to a power. We take the top, the numerator to that power, and divide by the denominator to the power. Now, let's work only with the denominator right now. We'll leave the top alone. On the denominator, we have a product to a power. This is Rule 4. It's like a b to the n. It's going to be a to the n, b to the n. We have a product to a power. We take each of the factors to the power. So 2 to the 3rd power times y to the 4th to the 3rd power. And now we're going to use Rule 3, which tells us when we want to take a power to a power x squared to the 3rd power, we multiply the power. So we get x to the 6th, 2 cubed, that's 8, y to the 12th. X to the 6th over 8y to the 12th. And that brings us to the end of the tape.